marking this as the right angle. This is the 60-degree angle, and putting the 30 up here. Remember that in the unit circle, our hypotenuse is 1 or the radius is 1, and across from the 30 degree is where we put the 1/2, meaning that this one over here is the square root of 3/2 based on our special right triangles that we studied, okay? So that means the x coordinate is 1/2 and the y coordinate is square root of 3/2. And so then we also equated that to cosine and sine and tangent, okay? So using this angle, we say the cosine of 60, remember SOHCAHTOA, sine equals opposite over hypotenuse, cosine equaling adjacent over hypotenuse, and tangent equaling opposite over adjacent, okay? All right, so finding the cosine, which is this one right here, we want to do adjacent divided by hypotenuse. So that means 1/2 divided by 1, or 1/2. It's telling us that this x coordinate is actually the cosine of our theta, in our case, cosine of 60 degrees, or cosine of pi over 3. Okay, and then what we could do is we could look at, I'm going to do a different color now. Let's take yellow. If we wanted to do sine of theta, sine of 60 in this case would be opposite over hypotenuse. Square root of 3/2 divided by 1 is itself. So that gives us that this one is sine of 60 degrees. Okay. And then if we wanted to do tangent, let's do a different color again. Tangent green. Tangent is going to be opposite over adjacent, which is this one divided by that one, which is the same thing as the y coordinate divided by the x coordinate. So anytime we have tangent, we're just taking our y over x here. So y divided by x coordinates. Okay, so this is just a quick review of the 3 basic trig functions that we've reviewed so far. Okay, we looked at it just now with our 60-degree reference angle, what that triangle, that reference triangle looks like, you know, and some of our terminology came out in our trig functions from within that approach. Okay. All right, so then what we can do is we can continue on past the 30-degree family, and we kind of looked at infusing these coordinates based on these special right triangles where you have the 30, 60, 90 and the 45, 45, 90 triangles. These are the special ones that get infused all the way through, and they provided us with our unit circle, okay? So our 45-degree family of coordinates, which show up in quadrant 1 through 4 with our positive in quadrant 1, quadrant 2 being negative positive, quadrant 3 being all negative, and quadrant 4 being positive negative, okay? So what this means is, since we said, and I'm going to highlight this, since we said that the, oops, that's not very good. That was not a highlighter. All right, let's try that again. Since we said that the x coordinates were the same thing as the cosine coordinates, that means that as we look at this, cosine is positive in quadrant 1, negative in quadrant 2, negative in quadrant 3, and positive in quadrant 4, okay? And then if we go to a different highlighter, let's go to green maybe, we can highlight the sine coordinates. Notice that the sine coordinates are positive in quadrants 1 and 2, positive, positive, and negative in quadrants 3 and 4, okay? And so if I were to take just a red pen and kind of indicate that, this is positive. Whoops, that's not, that's the highlighter. I want it back down to the pen. Positive, positive here, positive, positive, and negative, positive, and then negative, negative, and then positive, negative, okay? So let me erase this here, erase all of that. It's not going away. All right, so if we just focus in on the coordinates here, let's think about tangent, where that one's going to be negative and positive at, okay? We said tangent is to take the y coordinate and divide it by the x coordinate. So that means taking a positive divided by a positive. Well, a positive divided by a positive is still positive, right? Okay, so we'll just come back here. It's still positive, okay? In this case, tangent is a positive divided by a negative, which makes it negative. In this case, we've got our tangent being a negative divided by a negative divided by a negative is a positive. And in this case, we've got tangent being a negative divided by a positive, which is a negative, okay? So what we see here is that all three of our basic trig functions are positive here. Everything's positive. And this one, only sine, cosine, sine, and tangent, only sine is positive. And this one, only the tangent is positive because cosine and sine are negative. And in this one, only the cosine is positive. The sine is negative and the tangent ended up negative. So only cosine, okay? And so a quick memory device that a lot of people use going from quadrant 1 to 2 to 3 to 4 is that all students take, whoops, I missed that, calculus. All students take calculus. Helps you to remember from quadrant 1 through 4 which of the trig functions are positive. All three of them are positive here. Only sine, only tangent, only cosine. And then, of course, the reciprocal functions that we're about to get into will match the correct one. So if all of them are positive here, then all of the reciprocal functions, when you flip a fraction, it doesn't change whether it's positive or negative. So I'll call that the negativeness. Okay, the negativeness of it doesn't change just because you're flipping the fraction over, okay? But in this case over here, only the sign was positive. So when you flip the positive, that positive fraction square root of 2 over 2 over, you're going to get 2 over the square root of 2, but it's still going to be positive there, okay? So in that case, what we see is that with all students taking calculus, we can figure out, what our reciprocal functions would be. The easy one would be like the 1/2 if we had a 1/2, but these are square root of 2 over 2. So when we flip those, you have to be very, very careful because once you flip it, like this case right here, you get the 2 over the square root of 2. The problem with that is that now we have to rationalize this denominator. Remember, multiplying 3 by the square root of 2 in order to get that denominator to become a rational number, not irrational. Square roots, you can't leave radicals in the denominator, okay? But we don't want to square the value because squaring the fraction itself changes its value. Instead, we want to multiply by a value of 1, which means multiplying by something over itself. And if we already know what it's going to be over, then we just put that same thing into the numerator, giving us a nice value of 1 that's being multiplied. Multiplying by 1 doesn't change your output, okay? So this would actually become 2 square roots of 2 over 2 when you look at the reciprocal itself. So if you were saying sine was square root of 2 over 2 here, the reciprocal function would be 2 square roots of 2 there, okay? And so that's how it would work. So now we just have to set up what those reciprocal functions are. You've probably watched that in your videos already. And that gets us to our unit circle back in here, okay, with our circular approach, okay? So if we notice here, we have sine, cosine, and tangent. The reciprocal functions will be cosecant, which is the reciprocal to sine, secant, which is the reciprocal to cosine, and cotangent, which is the reciprocal to tangent. Tangent and cotangent make sense that they're reciprocals. Notice instead of y over x, we get x over y, okay? Those two make sense. They sound the same, tangent and cotangent. But the way I tell students to remember sine and cosecant and cosine and secant is the fact that sine and cosecant start with the different letters, and cosine and secant start with the opposite letters as well. So C goes to S, S goes to C. Don't put the two that start with C together. Don't put the two that start with S together. The cofunctions will not match up with the first letters of the alphabet, and that hopefully will help you. And here's a great way, a great visual representation. The reciprocal means flipping the fraction or putting 1 over that. And so cosecant and sine, secant and cosine, cotangent and tangent are reciprocal relationships, okay? All right, and then here's our positive negative chart and our all students take calculus memory device that we mentioned already. Okay, I'm going to write that in there. All students take calculus. So what this means is all 6 of the trig functions here are positive. In this case, of the 3, only sine is positive. So this would mean sine and cosecant would be your 2 positive ones here, okay? Tangent and cotangent here. And then cosine and its reciprocal, which is secant, are positive. Those are the only 2. Everything else gets a negative fraction value when you when you're trying to assign values, okay? So now let's do a little bit of practice here now that, oh, one more thing. When we're looking at, for example, our unit circle back here, if I were to say, what is the sine of 330 degrees? You would rotate around until you get to 330 degrees. Oops, sorry, I clicked. 330 degrees, and to find the sine, you would, let me highlight this. You would look at the 330 degrees at the y coordinate because the y coordinate equates to sine, okay? If I wanted cosecant of 330 degrees, I would flip that over and it would be -2, okay? So we could find sine or cosecant, okay? If I wanted, and I'll do this one in a different color, if I wanted the cosine of 330 degrees, that goes all the way to 330, I'm going to trace it all the way out. The cosine is going to be right here. The cosine, and then if I wanted the secant, I would flip that over, +2 over square root of 3, okay? Keeps the positiveness, and it flips over. I do have to rationalize the denominator, so I'd get 2 square root of 3 over 3, okay? But if I wanted tangent, what I would do is I would take this value, -1/2, and divide it by that value, okay? And if I wanted cotangent, I would take this value first and then divide it by that value, okay? Positive divided by negative means it's going to be negative. You have to do some fraction reducing, but leave it as a fraction because in trig, we want all of our answers exact and in fraction form. Decimals are only allowed if it tells you you can round to the nearest 10th place, 100th place, or something like that. The majority of time, as you can see in trig, we're not putting decimals around the unit circle. So the majority of the time, you're going to want to leave things as fractions, okay? So notice here in these directions, it says round to the nearest 10th. That means a decimal approximation is preferred. And you can probably guess that because this is not one of our multiples of 30 or multiples of 45 right here. Okay, so this isn't a special right triangle. So what we'll be doing is using calculators to be able to figure this out. How do we compute this? Okay, so it says find the missing side. The missing side is the one marked with the X. Okay, so that means we want the opposite and we only have hypotenuse. Okay, so we either need the fraction opposite over hypotenuse or we need to use hypotenuse over opposite. Those are the only 2 pieces of information. If you pick a different ratio, then you're doing more work than necessary because this side over here is not necessary. It's not asked for that information. It only wants to know the missing side, which is X there, okay? It's opposite, and then this one's the hypotenuse here, okay? All right, so if I wanted to do sine, cosine, tangent, one of our originals, it would be sine is SOHCAHTOA. Sine of theta equals opposite over hypotenuse. If I were doing hypotenuse over opposite, if for some reason that was easier for me, I would have to do cosecant of theta, okay? So that's the way that I would have to pick which one I wanted. Do I want to do opposite over hypotenuse? Is that easier for me to use in solving if for some reason that's the case? But what I'm going to do is I'm going to erase this one and just use it for board space, and we'll just go with the original trig function sine, not its reciprocal, okay? All right, so whoops, let me erase one more thing. So if we take a look at this angle here, you should notice that the angle theta in this example is 24 degrees. So I'm going to write that in there, 24 degrees. Okay. And if you're looking for the for one of the sides, which is what we're doing here, if you're looking for a side, you're going to use basic sine function. If you're looking for an angle, you will have to use sine inverse. That is something that you're going to have to get used to, okay? But we already know the angle, so we don't need to find the angle yet. If we wanted to find this other angle, we would just subtract 90 and 24 from 180, and we could get the other angle. Not a problem, okay? But in this specific example, we were given the opposite. No, we weren't given the opposite. We were given the hypotenuse. So I'm going to fill that in here. The hypotenuse is 283. So to solve for the opposite, which in our case was x. Okay, so I'm going to erase this and put the x in there just because that's how they've labeled it. All right, to solve for x, we will multiply both sides by 283. Okay. This is generally the idea. Once I get my tablet working for you guys, this will make it a little bit easier. I'm just wanting to make sure there's no glitches today, okay? So that means when we go to solve for x, it is by itself. We have x equals, and I can just type this into a calculator because it tells me to round it to the nearest tenth up here, okay? So that's literally just typing it in. But what you need to do, because it's in degrees, is make sure that whatever device you're using, whether it's GeoGebra, Desmos, a TI-84 calculator, which is what I typically use, but whatever device you're using, you will want to make sure that your mode is in degrees, okay? So that you're able to use that, okay? So practice with that, making sure you have that. Now, the other thing we could have done, if they didn't give us the 24 degrees, if they gave us two sides, then what we would have had to do would have been use sine inverse of the ratio that would have been opposite over hypotenuse here, okay? And so when we look at going the other direction, let's take a quick peek at an example like that. Actually, we'll get to that in a minute. Let's do this. This one, this direction says, I can't see it because of my thing up there. I want it to go away. But anyhow, it says to find all sine, cosine, tangent. You may even have to find secant, cosecant, and cotangent relationships there. So let's kind of do this together, okay? So let's think about the reference angle being where this person's at here. For sine, we will do opposite over hypotenuse, 9 over 10.8, okay? So we're using that definition for sine. For cosine, and if we needed to be exact, we would put this, but obviously we don't because there's already a decimal in there. So rounding it to 4 places as needed in this problem, we have 0.833, okay? Using a decimal in a fraction is okay because it's just part of our work, but typically we don't want it to have a decimal inside the fraction, okay? For cosine, we're going to do adjacent over hypotenuse. So we put 6 over 10.8, and then in the calculator, it'll give us a decimal approximation. Now, in your Newton homework, you probably can type this in or that in if it calls for an answer, unless it says to round it. Then if it says round, you'll want to put it that way, okay? All right, tangent is opposite over adjacent. So opposite is 9 over adjacent, which reduces to 3/2 or 1.5, okay? Now 1.5 is rounding to 4 places because the zeros don't need to be there. Okay, so you would leave that way. If we wanted to do our reciprocals, we would flip this upside down, 6/9, 10.8 over 6, and 10.8 over 9, okay? The other thing is if it says that we are in quadrant 2. Now let's do quadrant 3. Quadrant 3 is fun. So let's say we're in quadrant 3, but this is our reference triangle. Okay, so if we are in quadrant 3, then that means both sine and cosine are negative because both x and y are negative in quadrant 3. So this becomes negative 0.8333, negative 0.556, negative 0.5556, and negative 1.5. Okay. But if we're doing the reciprocal functions, what we would do is we would flip this over and then do the computation again, or do 1 over this number, okay? And then if we're still in quadrant 3, these two are negatives. This one is positive because tangent is the only one that is positive, and I'm trying to get back to it. Tangent is the only one that's positive here, okay? So regardless of which example we pick, we would want to do that. Now let's practice a secant. Secant 150. So rotate to 150, travel out that terminating side, find secant. Secant is 1 over cosine. Well, here's your cosine here. It's negative 2 square root of 3 over 2. Flip it. Negative 2 over square root of 3. And then you have to rationalize. So negative 2 square root of 3 over 3. Okay, so there are a lot of computations inside of this that are interesting for us to look at. The videos do a great job of doing that for you, but feel free to hang on with me after class today if you want to go through any specific problems, or if you need help understanding how to use our resources that are available in the class. Okay. All right, the last example that I wanted to show you in terms of the calculator, and then I'm going to pull up a calculator for us, okay? The last example is this one where it does not ask us to find a side. It gives us multiple sides. As a matter of fact, if you wanted to find the last side, just use the Pythagorean theorem because it's a right triangle. Okay, so anytime you have a right triangle, use the Pythagorean theorem and you can find the third side every time. So this time what it's asking for is we don't have any of the angles except to know that it is a right triangle. You must know it's a right triangle to use your trig definitions, okay? So finding theta and rounding to 4 decimal places, okay? So because we were given the opposite, this one's the opposite here, and we were given the adjacent right here, we were not given the hypotenuse, then this time our best ratio would either be tangent or cotangent, okay? And tangent of theta is defined as opposite over adjacent. I'm just going to put the O over the A this time, okay? All right, so opposite this direction would be 17.2 on the top because opposite goes on the top for our trig ratio. And then the adjacent, which is 9 here, goes into the bottom. But this time the theta is with the trig function. And in order to remove the trig function so that you're left with or solving for the theta that we want, to get theta by itself, we've got to undo the tangent. The undo is called the inverse. So we're going to take the tangent inverse of both sides. You can either call that arc tangent or tangent inverse depending on your calculator, okay? Tangent inverse of both sides, we want to take tangent inverse of this side as well. So in the calculator keystrokes here, it says hit the second button and then hit tangent. But each device is different. You may need to put an A tan or a tan with a -1 up here. There's a lot of different notation and every calculator is different. And so today we want to get used to how to use those calculators so that next week when we move into graphing, you will kind of have had some familiarity, I can't even say that word, with your graphing program that you're going to be using, okay? And so we'll take a look at some different ones that you can use today. And then this Friday, we will focus in on how to use the calculator as well as going through as many practice problems as you'd like from homework and study guide or any other resource. I even provide for you some sample quizzes that you can take to practice for your exam inside of our resources, and we can work on any of those that you would like to work on, okay, on this Friday. Friday will be mostly a work day, starting off with, you know, how to use the calculators, okay? Like I said, the next topic after how to use the calculators, next week, our topic will be on graphing. That is not this week, so we will get into this some on this Friday, but it is intended for next week's topic. So this is kind of our plan for moving forward. We'll be talking about calculator and so on, okay? All right, so let's go in and I use both GeoGebra. You're allowed to use GeoGebra, Desmos. You can use TI-84 calculators. You can use any of those for graphing purposes. So oftentimes there are, so let me see if I can just click. If you just click on this little ... here, it'll show you the different commands. So for example, here's your sine, cosine, tangent, secant. Cosecant this is the way that they do it there, or you can do A for cosine. That means arc cosine, and arc cosine meaning the reciprocal function cosecant. Okay, so these are the ways that they have it defined. So if you are unsure, you just click on the 3 dots and it will help you to see what your exact function needs to look like in order to be able to use it. Okay, so arc sine is here, but you could also use cosecant for that, for not cosecant. So arc sine or cosecant, which is this one. So these two are the same thing, and secant and arc cosine are the same thing. So these two end up being the same, and these two end up being the same. Okay, so you can use those to help you with this particular graphing program. Desmos is also allowed, and on Desmos, use your graphing calculator here, and on this one, let's see the functions that are allowed here. Do you notice you have your trig functions already pre-organized and your inverse trig functions are here? You just select which one. So on our last example that I may have just closed out. Nope, it's still there. On our last example, we had to put in arc tangent or tangent inverse of 17.2 over 9. So let's do that one in here. Okay, so we want tangent inverse, not sine inverse, of 17. It may have been different than that. Let me double check that. 17.2 divided by 9. 17.2 divided by 9. And we get 1.0887 and so on. So obviously I've done something wrong here. And so I want to pause because I know what's wrong, but I want you to help me know what I did wrong. What is going on right here that would give me a different answer than what I want, even though I typed in tangent inverse of the 17.2 over 9, just like I wanted it to be. And the hint is that this is supposed to be 62.38 degrees, but I ended up with something that doesn't say 62.38. Okay, this is so important. This is the biggest thing that people miss on the first test because the content on the first test is the easiest content of the semester. But this part of using a calculator is the part that most students forget to do. Okay, so what have I done wrong in this problem? Anybody have an idea?
Is it in the wrong settings? Like it should be in degrees?
Yeah, that's exactly right. We are trying to compute in degrees because the problem is in degrees, but I want you to remember that in trig, the main way that we measure angles is in radians because it equates arc length of the circle that we're dealing with. We're doing all of these circular movements and it's equating that arc length all the way back to our angles of rotation, just like we learned in class last Friday. So knowing that with our arc length, that we have to tell it that we're going in a non-standard way. Okay, so what we have to do is figure out where our settings are. Here we go. Let's see. This is giving me grids, X and Y axes. Look right there at the very bottom, something very huge. It is telling me that right now it's in degrees and radians is blacked out. But if I change it over, no, sorry, radians is the selected one. Degrees is off, the off button. But if I change it over there, look at what happened immediately. It switched without any hesitation to the result that we expected it to be. Okay. And so you will need to do this regardless of whether you're using a graphing calculator, Desmos, GeoGebra. Okay. You will have access to these even with the lockdown browser inside of your tests. So GeoGebra and Desmos, I will have links to. If you have a different program that you like using, let me know and I'll check it out and I'll let you know if it's going to be allowed on the test itself. But typically the only thing you can open with Lockdown Browser are the ones that I enable for you. And so that will happen. But you can also have a calculator handheld of any sort to use with yourself if you find that to be more useful. Okay, so feel free to use any handheld calculator. You cannot use a unit circle or any notes on the first test. On the second, third, and final exams, you will have included in the test, and also you will be allowed to use an identity page that I provide for you. Okay. All right, so we have about 10 minutes left. I want to see if there's any questions that people may have that you would like to ask logistically or content-wise about our course. Okay. Hi, Amaya. I see you are here. Yay. Go ahead and get the attendance today, Amaya, for who's here. So I did make this announcement at the very beginning of class, but I know a few people had trickled in. I wanted to let you know that today is the last day of mandatory reporting. Let me see if Celine is here. Celine is not here. Okay. So today is the last day of mandatory reporting. So I just wanted to make sure you knew that. That means today's the last day that I'll take attendance. This is mandatory, and so it's really important that you be here during these first 2 weeks. This Friday, we will be doing some logistical things. Like, for example, I will definitely be taking homework questions since this is a big week for getting a lot of the foundation done for the course. We'll be looking at our graphing calculators, whether it's through Desmos, GeoGebra, or you're by hand, and looking at how to use those and kind of previewing how to do graphing and also how to do this homework by using the calculators and not having, problems with that. But if you've noticed, I also include those types of discussions in the resources that are provided to you. Okay, so inside of D2L here, what we have is our resources. We have videos. Sorry about the grade showing, guys. That shouldn't have been still up. We have our instructional videos for this week. We have all kinds of stuff. There's even stuff in here about calculators. That's for the TI-84 if you need help with that, since that's going to be really difficult for me to show on my screen without a camera of some sort. You can watch this video if you're planning to use a TI-84. It's very comprehensive of the things that we're using in this class. So this is a great video for you to watch, okay? From this point on, there will be no attendance. There will be no judgment. Come and go as you please. Do not miss the deadlines on the calendars, okay? Also, please come on the Wednesday right before the test opens, because I want to make sure everybody's aware. The tests always open 9 a.m. on Thursday. We won't have class that Friday. That Friday, the test will be due by 5 p.m., okay? And then I'm also going to be talking about the bonus opportunity that will open after that. So I'm going to give you all of these details on the day before class. But as far as if you're good to go with just watching videos and getting homework done, then you can just drop in during office hours and ask questions, or even just drop in on a Friday. When Fridays, I'm devoting a good bit of the time to working through homework problems, and you can just ask your questions on those Fridays. So I wanted you to attend during the mandatory reporting period for more than one reason. One, so that, you're not dropped or withdrawn from the class. Two, so you knew how to get going with all your assignments and at what pace the class moves. Three, how to use your calendar and your resources. There's a lot of things that would have been impossible for me to get through just in 1 or 2 classes that we've now been able to do. But also I gave you a lot of background knowledge that doesn't come with your textbook and the practice that's there, okay? There was attempts made to add some of that into the, for example, this unit circle video here, to add those things in to make to help you feel better about the content, but I hope that this introductory that we've done so far has been really helpful, even though it didn't align with your homework. From this point, we will be staying very much a lot more close to the assignments and the textbook and the kinds of things, but also hitting some prerequisite skills without going into as in-depth of a background to get us going, okay? I think the textbook kind of assumes that you're coming in with a high school background introductory, just what's offered in the basic algebra geometry classes that you take in high school, okay? And I didn't want that to be assumed. And so hopefully now we all have a really good foundation moving forward. Okay. So like I said, you do not have to come this Friday. Fridays we will be talking logistically about everything from chapter 7. If you have any questions on that, that'll be a great day to come. Kind of treat it more like an office hour, although I will be previewing some things for chapter 8, going into graphing, getting us used to using the graphing devices, switching between modes, which would be radian and degree. In this case, later on, we'll get to polar mode as well and stuff like that. Okay. So we still have 5 minutes left. So I still want to see, did anyone raise their hand? No hands up yet. Okay. Feel free to just hop on if you do have a question.
I do have a question.
Go ahead, Sine.
Do you mind going over, let me see, I wrote it down. The cosecant, the cotangents, and as far as them being negative, positive, and the different quadrants.
Absolutely. I will definitely do that. And also, you reminded me, Sine, I wanted to also revisit arc length real quick. So I'm going to write that down again. S equals R times theta. I wanted to go back over arc length as well. So that's just a reminder for myself. But as far as the coordinates that you're dealing with, okay, so just remember all students take calculus. Oops, let me move this way so that we can see it better. There we go. If you remember all students take calculus, that will help you because this is saying for all, what that means is that you have sine of theta, cosine of theta, tangent of theta, all three positive, and then their reciprocals, which is cosecant theta, secant theta, and cotangent theta. Okay, so that's in the first quadrant. This is quadrant 1 right here. Okay, in quadrant 2, only only the sine of theta and its reciprocal cosecant are positive. So that means that all 4 of the other ones are tangent, are negative. So tangent and cotangent, cosine and secant are all negative. Okay, so all of these are positives. Okay, quadrant 3, that would be tangent and its reciprocal cotangent will be positive. All other ones will not be. They will be negative. And then quadrant 4 will be only cosine and its reciprocal, which is secant. Those will be positive. Okay, is that helpful? Did you have other questions about?
Yeah, that helps a lot. Thank you.
You're welcome. Very good question. All right, now let's get back to arc length. I know we only have 2 minutes, so I'm going to keep this very simple for right now. And I can revisit this like more in depth and why it's true. Whenever you have an arc length problem, you'll use this formula. Okay. Theta must be in radians to use this formula. Okay. So if you're doing arc length, you must convert your theta from degrees to radians. It has to be in there. That's the condition. So it's a condition of being able to use this formula. Okay. And so if, for example, your radius is 5 and your angle is 60 degrees, and so you've rotated from, let's say, from here to 60 degrees inside of the circle, okay, and you're wanting to know what this arc length is right here, and this is 60 degrees. Okay, so let's say that's our picture, and this is a unit 5 units, okay? Then to find S, you would have to convert this to pi over 3, okay, times 5, and then you will get your arc length approximation as a decimal, or you could answer it exactly as 5 pi over 3. So this is your exact answer, or you can put it into a calculator and get a decimal value, okay? So 5 pi over 3 would be exact, but the decimal approximation would be 5 times 3.14, which is like 15 point something, divided by 3, which is about 5 point something. So this is going to be approximately 5 point blah, 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 whatever it is. If you're depending on how many decimal places you need. Okay, so with a calculator, you can do that. That is in a nutshell how you compute with arc length. Okay. On this Friday, I'll make sure to come back and hit arc length. Graphing calculators, of course, homework questions, anything like that you need. Anything else you'd like for me to add to the agenda for Friday, you can either email me, stay after, whatever. Just let me know. If you have specific homework questions you'd like for me to go over on Friday, you can email me in advance and I'll prepare to have those ready for you. Any of those types of things, okay? So we have run out of time. Feel free, attendance has already been taken. Feel free to hop out if you're ready. But if you have questions, please hang around. Sine, is your hand still up or is it a new question?
Yes, I was just going to say, or I was going to ask, so are you basically saying like anytime we deal with arc length, it's always going to be, it has to be in radians to get the correct answer?
Only if you're using that formula, Sine. So let's say, for example, you can find the full circumference of the circle to be, the circumference is pi times diameter. So there's a formula, geometry-wise, right? And let's say that your angle is 90 degrees. You don't have to convert 90 degrees because 90 degrees is a fourth of the way around. So you're just going to take 1/4 of whatever that circumference is. So you can use fractional ratios or relationships inside of there without having to convert to radians. If you're using this formula, it must be in radians.
Okay, thank you.
You're welcome. Feel free to continue asking questions. Your questions have been excellent. They've helped me to know that you have been doing work and that you're running across that you're identifying the things that you struggle with or that you have some problems with. So that is fantastic, Sine.
Thanks.
You're welcome. All right. Anybody else? Tiara, stay on with me.
I have a question.
Nafisa, go ahead.
Will the recording be put on D2L?
It is not in D2L of the class. The recording posts into the course in Teams. So if you access the Teams, let me go in here to our chat, for example. If you take a look, it's downloaded the attendance there. There's the recording from the last class, but it takes maybe sometimes up to an hour before it posts. Then I can keep going back and you should see another video further up. They do not last for long. The videos are, because they're quite long, they only stay for a couple days. But if you need to go back and revisit them, come back into here and grab them from there. Okay, so I definitely saw this one from last Friday.
Okay, thank you.
Well, I think they're good for a week, approximately. Okay, Sine, I see your hands up. Let me check with Angel and Donovan first. Do you guys have any questions for me? Oh, they're gone. All right. Angel, any questions? Okay, so Nate, go ahead with your question then.
Where did you say we can access the practice quizzes that prepare us for the unit test?
Okay. Yes, that's in D2L. I can show you that right now. So right here, let me do this. Okay, so they are now visible to you in D2L. Yours may look a little different, but if you go under all the way down to the very bottom, it'll be the last thing. You won't see these videos down here, okay? So it'll be right under the study guides.
Okay, so the quizzes are just for practice. These are not required, correct?
Correct, yes. I only do the quizzes in class, either hybrid or fully on campus version, because as a fully online student, you have more work to do. So I just leave them as practice and not as graded.
Thank you so much. Have a great day, and I'll see you Friday.
Thank you. I will see you then too. All right, Tiara, thank you for hanging out with me. Sine and Angel, you guys can go ahead and hop off. I don't think Angel is still on with us, Tiara. Oh, she is. There she goes. So are you here? Can you unmute yourself?
Yes,
There you go.
I'm here. It's just at my background. I'm around a bunch of servers, so I didn't want to.
I just wanted to check in with you because I know you missed some of the days last week, and I just wanted to see if you had any questions or any trouble with getting things going in class.
How many days I missed? From my understanding, I've been in class.
You've been here every day?
No, I missed Monday. I only missed Monday.
Oh, I had Maya took attendance on Friday and she had you missing that day. Okay. Well, if you were here every day but Monday, you're good to go. You are totally good to go. I just had you missing one extra day. It doesn't really matter because you've done your work and that's really what, all that matters for me. Actually, let me double check the grade book just really quick to make sure everything's caught up for you.
Okay.
And I'm going to unshare my screen just because I don't like my grade book to be showing, even though we're early in the semester. That's irrelevant.
Right.
And everybody's done everything. So that's not even an issue. Me showing you hundreds. Yeah, you have hundreds on everything. So that's fantastic. You're doing good. So you know that your next set of homework is through the end of chapter 7. And then by the time we finish graphing in chapter 8, that's when we're going to have our test. Okay, so keep an eye on that calendar, and if you have questions, just let me know, okay?
Okay, and thank you for checking with me. I didn't know she had me. I know I came in late, so that may be why, but I don't know. Okay. But I know I missed Monday. That was the day after my birthday.
She probably took it at the beginning and didn't check it at the end. That's why I typically like to look at the end of class. But we don't need attendance anymore. It's totally up to you whether or not you come. I just wanted to make it really clear that you could, that you could ask me questions about how to get started and stuff. And it looks like you had a good start though. So I apologize. I really thought you missed more than one day. And so I was checking.
Thank you. I appreciate you checking because most people won't even have checked. So
you're very welcome. And good luck to you. Have a great rest of the week and maybe see you on Friday. And if not, just make sure to pop in the Wednesday before your next exam. Okay.
All right. Thank you. I appreciate it.
You're welcome. Bye-bye.